Hello everyone, this is assignment 16, question 43 from the Oxtoby textbook. In this case here, you're given a solid sample of pure naphthalene and you're burning it in a constant volume calorimeter, so in a bomb calorimeter at 25 degrees. So you're given the fact that you have a constant volume calorimeter, which means your walls are not going to change, very rigid. You have a mass of naphthalene, so put delta V equals 0 here. Volume, your temperature is 25 degrees Celsius, and you're told that for that particular mass of substance, that 25.79 kilojoules of heat is evolved. So that means it's going to be a negative value. That means it's losing energy, it's losing that heat, so it's going to be negative. A few things you want to get out of this. Part A, write a balanced chemical equation for this. So this is going to be part A. So you are given the formula for naphthalene, which is C10H8. And when you do combustion, you're burning it in oxygen. And you're making CO2 and water. It's important to know the little phases over here. So naphthalene is solid, like your mothballs. Your small mothballs are naphthalene. O2 is a gas, CO2 is a gas, and at 25 degrees, water is a liquid. So here's your equation that you're using. We want to balance this. You guys can go ahead and try balancing that. The more important things to look at your carbon first, because you know all the carbon ends up in CO2. Remember first semester, we did questions like this. So that means you're going to have a 10 here. All your hydrogen ends up in water, so you're going to have a 4 there. And then you can just go ahead and balance out your oxygens. You're going to need to have a 12 over on this side. There's your balanced equation. Now part B wants you to calculate the standard change in internal energy. So we want to find delta U naught per mole, so for 1 mole. So we know N is going to be equal to 1 mole, in this case here. You know if delta V is 0, that's a V, not U. That means work equals 0. That means heat equals delta U. So I have a value for delta U, but this is the amount of heat that is evolved for that many grams. We want to know per mole. Okay, so this is a kilojoule per gram. Well, if we do divide that out, kilojoule per 0.641 grams. We want to find per mole, which means you need to switch this into moles and divide that through. So your molecular weight for naphthalene is 128.173 grams per mole. So you end up with a value for moles of 5 times 10 to the minus 3 moles of naphthalene. So if you have minus 25.79 kilojoules, or 5.0 specific, times 10 to the minus 3 moles, then you're going to get your value of delta U, which is going to be minus 5.157 times 10 to the 3, this is in kilojoules per mole. There's your answer there. Now let's erase some of this. I'm going to keep the equation on there for now. And we're moving on to calculating the enthalpy change for this reaction. So we want delta H naught. And if you remember, your delta H equals delta U plus delta PV. So in this case here, this heat isn't necessarily enthalpy. You have to look at the circumstances. Heat, if this is constant volume heat, that is delta U, which is in the last question. Delta H is going to be a little bit different because you have this other factor in here. We don't know the pressure and volume, but we do know if this is an ideal gas, delta U, you can change that into delta nRT. When you're doing this, you're going to assume your temperature is 25. Well, you know you're told it's 25, that's going to say constant in this case here. You're doing the reaction at 25. delta N, this is our change in moles from before and or after and before, so from products to reactants. We don't care about solids and liquids. They're not going to change our pressure or volume at all. What they're going to do, and what's going to happen in this case here, we only care about the gas. It's the only thing that's going to do that little bit of pressure volume work, if you will. So we're only going to look at our delta moles of gas. So you're looking at your amount of product gases, which we have 10 moles of product gases, minus your reactant gases, which we have 12 moles of. So we have a delta N of minus 2 moles. So you can go ahead here and do the math for this equation. So delta H equals our delta U minus 5.157 times 10 to the minus 3. That's in kilojoules per mole. So you have to be careful because you don't want to mess up your units. So we have minus 2 moles. Your R is in joules per mole Kelvin. We are at 298 Kelvin. So you're going to have to multiply this part here, or sorry, divide this part to get your kilojoules. Okay, so make sure you turn this into kilojoules, or this into joules. Either way you want to do it. Sorry, that's not minus 3. That should be plus 3. Okay, that should be 5,000. So doing that, your delta H becomes minus 5,162 kilojoules per mole. So that's the enthalpy of combustion of our naphthalene. And the last part of this question asks you to find the enthalpy of formation of naphthalene from this and also from using your appendix D. Remember, enthalpy of formation, or where you can get those values from, your enthalpy of reaction is made up of the enthalpy of formations of the products and the reactants, right? You're taking the sum of the enthalpy of formations of the products minus the sum of the enthalpy of formation of all the reactants. So in this case here, most tables are going to have CO2 and water in the table, no problem. The enthalpy of formation of oxygen, which is elemental species in its standard state, which is gas, this is going to be 0 because nothing's changed there. So from that, you're going to know, you also need to know your moles. Actually, so let's write that out. We might as well write that out. The delta H naught of reaction, if we add together our products, that's going to be 10 times the delta H naught formation of CO2, because you have to take into consideration these stoichiometric coefficients, and that's of the gas phase of this one, plus 4 times delta H naught of formation of water, minus, leave oxygen out because that's just 0. So you're going to be minus delta H naught of formation of, I'll just call it naphthalene. So you should be able to go through, solve for this. So this value in the end, because your delta H naught of reaction you got from part C. So this should be 83.6 kilojoules per mole.